Thank you, thank you. Thank you, kind people. Welcome to another episode of our world-famous and critically acclaimed talk show called Zero to Billion. As you know, we invite guests who have remarkably accelerated in their domain. Now, these are companies that shape our future and transform industries. But before moving on with our guest, I would like to thank you, kind people, for coming here only to watch the show online, live from the audience. Give it up for yourself. Hey. I'm very thankful, especially because, the tickets are very expensive. Then again, you guys know, working in the tech sector, you're fine, right? I mean, you guys probably make more money than the president. So, why are you laughing? It's the way it is. It's okay. No shame in that. It's the other sectors we're worried about, but they can stay home, watch it live because we are recording. Camera 1, 2, 3. Now, on with our next guest. This is a miraculously successful tech company from our very own small town of Tartu, called Car Rental Gateway. They claim to have made 4 million vehicles, car rental vehicles, around the world available to travel sites via single API. Imagine that, 4 million vehicles in one API. So what they've done is they've built API connectivities to these car rental brands across the globe. And these include like mega brands like Hertz, Avis, Budget, Enterprise, all those big brands you've heard about, but also regional and local ones that you've never heard about. And by doing that, they have access and real-time availability to the content and inventory of these car rental locations anywhere in the world you can think of. What an amazing business case. So they aggregate this global car rental content and they provide it to travel sites via single API. But that's not all. So post-COVID, they set their sight on digitalizing the traditional car rental journey, so to speak. They built an app platform that communicates with connected cars. So now, not only do they have access to the content, they also have physical access to the cars. Now, together with another Estonian company called Liigu, they are applying this technology in the car rental sector, and they are revolutionizing the user experience in the car rental industry altogether. But enough of me talking about it. Let's hear it from one of their own. Ladies and gents, I invite to the stage Rajan Raj Das. Give it up for the man. Thank you. Thank you. Thank you, Martin. Hello, Rajan.
Hello, Martin.
How are you doing?
I'm good. How are you?
I'm doing well. Before we talk about Car Rental Gateway and this amazing use case that you want to present, let's talk a little bit about you, because you also have an amazing story to tell, right? Because you're not from around here, are you?
Yeah, as you can see, I'm not from Estonia, and I'm originally from Nepal. Born and brought up there.
Wow, Nepal. What a journey that might have been. Like, when I think about Nepal, the only image that I get is mountains and temples. Is that true at all?
I think you have really strong sense of imagination, and that is exactly true. So this is me in front of a temple in Kathmandu.
All right.
And I don't know why my team put my pictures on top of mountains, but I've never seen mountains because it's really expensive and to go on top of Mount Everest or go for any hikings.
Oh, so but it's not like kids playing on top of Mount Everest.
No. As a matter of fact, just to climb up Mount Everest, the basic package is $30,000.
Oh wow! Okay,
which is pretty expensive.
Fair enough. Okay, no mountains, plain areas. So you're familiar familiar in Estonia. You always get plain
I
areas.
feel pretty much home.
Right, okay, good. So what brought you here?
Originally, I came for my studies at one of the best university, I would say, University of Tartu, which is a hometown here in Tartu itself.
Amazing. And how did you end up in Car Rental Gateway?
That's an interesting story, I think, as well, because everyone got to work, right? So you cannot just study and live your life.
Or you can make shows like me.
Oh, yeah, easy money. So
It's not that easy. I mean, I had to prepare.
So yeah, I was just looking for the list of perspectives, like companies that are in Estonia, and specifically, I'm interested in mobility industry. I'm really interested in that, so I was like, let's find out what are the companies in Estonia, and specifically Tartu, because I was studying back then, and I was still like, I do not want to move away from Tartu and just for the job or something. I still want to continue my study. And that's where I was like, there was a company just walking distance away from the university building. I was like, what? And I researched about it. And matter of fact, Martin, it's not like simple startup which is just changing the world. It has been here for the last 23 years now. It had started in 2001.
Uh-huh.
And they survived 2 recessions. So it is pretty much stable.
Well, that is an interesting fact because I have to be honest, I hadn't heard about it before today.
Now you know. And also the other fact is like some people might never heard about it because we are B2B mostly, and as a fact, like we have footprint all over the globe. And last time we were just checking how many people from which country book via our platform, and we found out there's 2,205 countries. Resident countries which booked via our platform, and which was like, whoa, that is something. And other fact is like you might surprise, like we make 3 billion, we get 3 billion requests in a month.
3 billion in a month?
Yeah.
Wow, you meant a year, didn't you?
No, it's a month. We can handle that big request load.
Wow, like that's even more than the company, the Estonian government's Environment X Road makes in a year. So congratulations. What does a system like this even look like? Can you explain or maybe even show it to me?
It's really difficult to put it in words or show you the source code because it's a million lines of code. So
we have a
it's
big
not
screen.
Possible. Oh, but this might be really small for that as well. But I have an interesting thing for you. I'll just show you the blueprint, how it looks like. So this is the scale of our system, how a system looks like in production right now. And this is just part of it. These are just the services which communicate via RESTful API and messages queue. And these are just these. And there are many more background services and cron jobs running at the background. And to be precise, there are 196 services right now running in production. I just checked it before coming to the stage.
Oh, wow. Well, it is amazing. It kind of looks like a brain, doesn't it?
It does.
Yeah, but an active brain. Not like mine, but rather like yours. So how do you build a brain like that? Or, what does it take?
I think the answer is simple, Martin. You need a developer.
Right. Yeah. Well, let's say we have a smart guy from Nepal. We've got a developer. What next?
Every developer needs their tool, their development environment.
Right, okay. Also, very simplistic approach. I mean, every developer has a development environment. Can you elaborate a bit?
Sure. I think many developers here have really narrow way of thinking what a development environment is. Or they just think that a development environment is just their VS Code or IDE that they have installed in their system. And I think it's right, but it's much bigger than that. A development environment is something like a process, a set of tools that you use to write your source code for an application. And whatever you write in your development environment, when it goes to any other environment like staging or production, it should not fall apart, right?
Right.
Because, many developers suffer when something happens in production or not staging. So nobody cares staging, I think. Because just push to staging and to the product. Nobody tests on staging and then go to production and then you start testing, which is a really bad practice. You should always test. And so all in all, I think a development environment is a safe working space where any developer can make code changes, test it out, be confident that it is working. And also, when you are making changes, you get the real-time feedback about what changes that you're making and what business logic you're implementing. And on top of it, I don't know, I have never seen a developer who goes into production environment, going in SSHing and the production container and then checking the logs there and trying to debug it. So in that sense, you replicate that bug in your development environment and try to figure it out what are the logical and what are the mistakes that they have done. So in that sense, it makes your debugging faster. So I think in simplest form, development environment is this.
Right. Okay. Very holistic view into a development environment. So may I ask, what do you guys use as a development environment?
At Car Rental Gateway, we are using Cloud Stack.
Okay. Never heard about it, but
I think nobody has heard about it because it's our inbuilt tool, in-house tool that we built for our use case, because all the other software that we were using, it's kind of creating problem for us, and it's really problematic to just keep maintaining it and working with it.
Sounds like an interesting story. Can you talk about it a little bit?
Yeah, let's talk about it. Yeah.
Yeah. Okay.
So start with like any application or any startup, they start with the monolith, right? So they have their monolith set up, and in order to build that business application, you start simple service, and you push that service to the production environment. And any company or any developer, they will just set it up locally there. Like in our use case, we had the PHP monolith back then. So what we were doing is like we were setting up the XAMPP server and database, everything locally, and also making sure that it matches all the configurations that they have it in production, so that any changes which is going there do not start falling apart when we pushing it. So in that sense, it was really nice and small and easy to maintain. But the problem was with the setup. Let's say we want to start your own, like let's say there is a new developer joining in, and you have to set up their development environment. And I think every senior developer here knows the pain of it. Like you have to sit with them for hours maybe, and then set it up, everything step by step. And many of us even do not remember that what we did like 2 years ago, how we set it up. So you have to read the documentation again and everything. And there are too many configuration overhead that you have to do, as like add some environment variable there in JSHRC, or add some configuration value there. So in that sense, it was too problematic. And then we were like, let's find a good solution for it, like how we can avoid these slow processes. That's where we came across a tool which was already in the market, which is Vagrant, and I think many people are still using, and it's a good tool, but it didn't fit our use case because, first I will explain about the Vagrant, how it was working. So everything was like boxed in a container or in a virtual box. So it's easy to spin up. So whenever you want to start anything, simple configuration of something like hour, and then you are easy to start. And whenever you want to start and write code, you can simple command, and you're ready to code. But the problem with this was, it was like, monolith. For monolith, it was really good, and it was nice. But at one point, we were like, our business is getting bigger and bigger. We need to scale really fast. And for that, you cannot scale in monolith, right?
Okay.
That's where we were like, let's move into microservices because of its benefit. And I think many of you already heard many conferences and many talk about microservices, and everyone is talking about it, microservice architecture. I'll also give a small talk about it, the benefits of it, which is like, you can work parallelly so that no one gets affected, no other service is affected. You work in a single and smaller scope, and it's easily deployable, and you can do as many development as you want in a day. Some people even do like 50 to 100, which is crazy, I would say. And also there is like independent technologies. As I said, our monolith was still in PHP, but there was like different use case need different technologies, and we need to adopt it. And you cannot just migrate your monolith from from PHP to something else over several months. It takes years to build it. So migration is also takes years, I think. So we were like, let's go with microservice architecture. And it was really promising. And we did it as well. We started breaking some of the components from monolith. And also the new features that were coming in that we were implementing in a fashion that it's talking to monolith and it's in a separate service, in a microservice.
So that fancy picture is not yet CloudStack?
No.
Okay.
I'm just talking. I'm just setting the plot
Take
right.
your time.
Yes, I'm setting the plot right now about the story. So that's where we were like, let's use a solution which is, I think, easy, cost-effective, and easy to set up. Like, you're still building your monolith, and if you're working with some services, you run it locally, and you make requests against a shared environment and verify the changes that you're making. And that was really nice because everything was like in shared environment. Everyone was making requests against it, and cost-effective, yes. The problem arises when some people were experimenting in that shared environment, and also like it was really some people had only access of it. So it was an issue that if as a developer I'm just a junior, let's say, I want to make changes, some configuration changes in shared environment, I have to bother a person and talk to him. Please, can you configure this, that, and which was really problematic. And also in shared environment, the workers that we were working with, like mostly the async workers, were really problematic to work with. And the story was like once a developer was like, he was the only one who is already always experimenting with the shared environment, and he was like always used to misconfigure something or bring down the service down. So because of that, all these all these development process was getting on halt because you cannot make requests to that particular service. And usually it was like important service like authentication service. You need to get the token and you need to make requests to different services and authenticate that what access that a particular user have and blah, blah, blah.
I understand the problem. Yeah, when I was in gym class at high school and someone forgot home the training clothes,
okay.
Yeah, everybody got punished. So, yeah, been there, done that. So,
so
we ganged up on that guy.
Oh, yeah. We were not that harsh, but like some people were like, they explored their own way. They started running everything locally. Not everything, but they started using their local environment as well because they were like, yeah, I'm not using it, let's use it. So they started using local environment to run some services, important services, and still they were using shared environment and their monolith they were running in Vagrant. Too many things, right? And it will get out of hand soon, and it is really problematic to manage all these configurations because in order to run services, many services locally, we were using some process managers, and as Martin said, people ganged up. So there was also people in our company, the several teams who would ganged up. Some people were like, we will use this pre-existing tool in market, which is PM2, which helps you to manage all these processes. And some people were like, yeah, that tool has really limited feature set. We will gonna build our own and work with it. But the problem was, it needs lots of configuration because you need to start writing all this configuration that all these services will have. And some of them, you can see on the screen, the templates and the configuration that it needed. Also, running too many services will run your computer like a jet engine, because half of the memory RAM is taken up by these processes and remaining half is taken by your Chrome browser, I think, which is pretty heavy. That's where we were like, yeah, that's really foggy and really non-standardized way of doing it. The problem with it was, different people were doing different things in a different way. So, for example, if a developer from one team want to move to another team, they have to learn this development things, how you test out, how you run the things separately, how you do things, everything all over again, which is like really problematic and steep learning. I would not say steep learning curve, but some will get easily, some will take time, and it's a waste of time, all in all, like as a business. And also these tools were like really, as I said, like limited feature set and really problematic because the tool that we built, DevStack, we call it DevStack, it used to freeze up the system because of this memory leak problems. So that's where like it was like too many problems.
Yeah, I noticed you talk about problems all the time, but this is a show about successes. So yeah, come on, let's talk about how you got to the successful part. I'm also conscious of time.
Yeah, let's do that. But I think every problem, in order to have a solution, you need to have a problem.
Yeah,
so we were creating problems.
Absolutely. Oh, you were creating it.
Yeah, we were creating a problem on purpose.
Find the perfect solution.
Yeah. So that's where we were like, every developer came together like, no, this is like too standard way of doing things. We need a really sustainable solution. And that's where we came together, our lead architect and all these other developers. We came together with a requirement, like what good development environment in microservice environment looks like. And some people are like, yeah, we are fed up and we lost our trust against this shared environment. We need something which is isolated, where we can make and break things that we wanted, and nobody's affected with it, and I can do my own experiments. And okay, that is nice, because yeah, you want to be like, create something innovative, go for it. And other was like, yeah, there are too many services. I want something simpler to orchestrate these services easily, start some, stop some of them. So yeah, and which is understandable, because too many services needs too many resources as well. And there was like resource management problems as well. So we need something which we can easily expand the resources and contract the resources that these services are taking, or you want to start or stop the service, which will also help in resource management. And also support for different technologies, because we were already in PHP, and we went for Node.js, and then now we are still experimenting with Go. So we were like, and there is mobile team, and then there is front-end team, so all have their specific technologies. So we need this support for everything. And also simple requirement like debugging and monitoring logs, because all these process managers were really problematic, because you have to go into log files, check the logs, and it's not simple to do that. So these were the requirements we came up with.
You got the team together.
Yeah.
Everybody put in some ideas, and you ended up with the requirements for CloudStack.
Yes.
Right, finally.
You got it right. So yeah, that's why we were like, let's build our own tool called CloudStack. That's why none of you have heard about it. And a CloudStack is a simple tool, which is a command line tool to provision resources in AWS. And you can work with local system as well as remote system like at the same time. So whenever you want to switch between resources, like some services you want to run locally, simple command. If some services you want to run remotely, simple command. That's flexibility you want to give it to the developers. And also you get the private workspace. So this entire cloud's workspace and this local is yours. So you can do whatever you want to do. And also this code sharing thing, which was like, if you want to give some code review, or if you want to give away some working things to your fellow developer, they do not want to pull in, configure everything, and start running it, right? So we just were like, let's build some features, which was like, you just give the branch name, and people will just write that branch name, and that service will start working with that particular branch in their CloudStack, which was really nice thing we built.
It sounds amazing. Where can I download it?
Sorry, we are not selling it, but we are thinking of it, outsourcing it, the minified version of it, because it's too to build for our use case. But the minified version, we are still having debate in our company, like which feature to outsource. But today we have really good talk. So we will we will talk about the architecture, how we build CloudStack, so that many people and many developers here get an idea about how they can build their own development environment. And also, if you're already using some development environment, or if you've already built one, you can add some features that we added in order to maximize the developers' productivity.
Okay, fair enough. I can't download it, but maybe I'm a man of visuals. Maybe as that big brain of yours, maybe you can show it to me or at least explain a bit more. Yes, there are some visual guys also.
Yeah. So for you, Martin, I have a simplest view of Cloud Stack, how it looks like. So a simple Cloud Stack looks like this. So every dependent service that you want to run in order to test out the entire business flow, you run it in cloud. And if you're working with some changes, you work it with local system. So in locally, you run some specific services or some services that you are working with right now, code changes, and save it and run it. And everything else is taken care in cloud. And the cloud is limitless. So you can have as big as possible, like as much resources as you want. And this is a private cloud stack.
All right.
So that means it's your private cloud, and this is your private EC2 instance on the cloud.
Amazing. Well, thank you for simplifying it just for me. But our viewership here consists of very smart people and even geniuses. So maybe
I agree.
we can break it down a little bit for them.
Sure. Just for the developers, yeah. So let's start breaking down into smaller components.
Right.
To start with, let's talk about the cloud infrastructure. So what we did was we used CloudFormation, which is provided by the AWS, just to instantiate some resources in the cloud environment. For example, in order to have run something on top of some CPU or something, you need some resources, some resources in the cloud. So in CloudFormation, we defined what we need, which was like simple Lambda functions, EC2 instance, the file systems, which is needed to run our services. So we defined everything. And also these Lambda functions were programmed to keep monitoring this EC2 instance in order to check how much memory it is consuming so that we can expand it on demand. So you do not have to think about it like I'm running too many services or something. And also these Lambda functions will sleep these entire infrastructure when your work hour is over or whenever you want to sort it down. So this was like really, because CloudFormation provides you the infrastructure as a code thing, so you can create your own infrastructure or transfer it from one place to another or replicate the other people's infrastructure easily. So on top of this resources that we instantiated in the cloud environment, simple, we installed the orchestration tool, which we used Docker Compose. Many people will argue here like Kubernetes is also good. Like for our use case, we just went with Docker Compose. And inside that Docker Compose, we were running all the services in that. And this monitoring services and this logging services were also built. The log gathering services was also built in that itself. And all these services which was floating around were connected by a tool called Traffic, which is a proxy load balancer tool, which can be dynamically configured. So you just have to run your services in Docker, and it will just register itself because it is really compatible with the Docker Compose. And simply, you run everything, and easy to set up everything. And whenever you want to start some services, what we at the background, what Cloud Stack is doing, simple. You write simple command, which is our command is cs start some service name, cs start service name. It is going in the EC2 instance, SSHing into the EC2 instance and running a command to run that particular service.
Okay.
That was pretty simple.
Right. So now you talked about running everything in the AWS cloud, but how does it help a developer working with the code locally?
Yeah, the tool which is called Traffic, which is really nice, I think, because the tool will know whether as it is a load balancer, you make request against it, and it will register that request and then see whether I have the service running it in the background, like in the backend services is there. And if it doesn't find that service, it redirects it to your local system because it was already configured based on your IP when we configure it. And simple, you make changes, and if it needs some external services or it needs to make some external services, it will make actual request and then get the response, and it will go via this load balancer all the time.
Okay, and maybe explain a bit how developers are using it.
Yeah, for developer purpose, we build a bunch of features around it, and we are still building many features just to make our life easier. So some of them are listed here, and there are many more, by the way. And I will just explain some of them, and then we can we can think about how cloud stack looks like. First of all, it's like CS clone. As I said, like everything is infrastructure, it's template based, so you can easily clone someone's infrastructure easily. So you just write CS clone, and it will clone the entire infrastructure your fellow developers is running, and also the configuration that they have in Docker Compose, and start your own development environment. So you do not have to go through this rigorous process of like, what are you running? Like you do not have to ask your fellow developer, what are you running? I want to run the same services in I want to build this same feature. And it is really problematic because you keep bugging people, and they get irritated. Another feature was CS checkout branch name, which is, as I said, like code sharing becomes really easy. So just share the branch name, and then people will check out to that branch for that particular service. CS checkout branch name with the service name, and they can easily run the service. And on top of that, I think every developer here, I would not say for the senior one, because we love to read the documentation, but the new developers, they're like, oh, this is not working. How do you run it? And they do not like to read the configurations, how to set up.
I hate it.
So for them, we build these features like CS Get, and which will just pop out all this configuration that you need in order to run that service locally. So you do not have to read through any documents or Confluence page or bunch of things just to get started. You can just easily write it, configure your environment, and then start running and making the changes. On top of that, there is CS Start and CS Graph. CS Start is basically when you want to start any services, just by your username. So you do not even have to remember what is the configuration, what's the port number, what are these the URLs they have. Nothing. You have to just remember the service name that you are working with. And CS Delete, CS Graph, which is basically creating the AWS resources or deleting the AWS resources entirely.
Right, but look, this is all too very complicated for me. So maybe you have an example. Maybe you can show it to me.
I'll show you the use, how people are using it. So in that sense, how they write a simple command in terminal, and then they can easily see the output. So for example, one of the command is CS top, which will list out all the list of services that you're running in the background in the cloud environment, and the memory it's consuming, and in what is the process idea for those. For front-end people, it might be like, it's useless because they never care about this. For back-end people, like sometimes you want to run some load testing on particular services, and you see what are the memory consumption and how it is increasing. You can use this as well, but there is a UI that we build on top of this. Not we build, but like there is already pre-existing tool, which is Grafana, we're using on top of our monitoring and logging service. And this was one of the command. Similarly, there is another command which is CS Graph, and it is simply like everyone want to test, like just to have a confident testing. You just want to see the changes that I made will do the entire flow or not. Like let's say you're doing the booking, it should do the entire process, right? So to do that, you have to run the bunch of services and check whether it is working fine or not. And let's say you're working with one service and you don't know what are the dependent service for it, like what should I run in order to test the entire flow. So you just write CS Graph, and then it will give out all the dependent services that it needs to make, it needs to make the request against. So that was a simple, like some of the features that we built for the developers.
Quickly, how does it help a developer? So what are the benefits?
For a developer, I think one of the important concepts, like when you're building something, is developer feedback loop. I think many other fields as well use it. And for us as well, it's the same. Because when you're writing a code, you want to have it easily tested. Like you just want to write it, test it. It is working, that's good, like perfect. And in the older times, I would not say it's really old, but like let's say 2010, when you're working with these big systems, you have to write the code, sync it in somewhere, like in some virtual box or some cloud environment, and there it will run the E2A test, integration test, bunch of code quality test and everything, which is really, really time consuming because you have to wait till everything completes and then start optimizing the things that you're doing. In that sense, the confident testing that I was talking about, or the smoke test, you can do it easily and just build everything, write it, push it, and then you can think about something else in the meanwhile. You do not have to check what are being done in this outer loop. So in that sense, it minimizes the developer's feedback loop, and they can build the feature faster and innovate really fast.
Right. It sounds like a dream, actually. But hey, Rajan, time has flown. Maybe we can take a step back and maybe you can please summarize how CloudStack helps with the development process in general.
With development process, we already talked about it, like much of them.
Right.
But it also had like company-wide, or I would say like for a new developer, really good features and benefits. So we already talked about the faster feedback loop, easy debugging, and for a new developer, or if you are like already working with a development environment and then your system got messed up, you want to set it up again. So for them, the onboarding becomes really easy because you just have to write simple command in order to start your entire infrastructure with all the services that you're running. And it is super simple. You do not have to sit with a fellow developer and drain your energy all day just to get them started. You just give them some documentation. They will be easy. And it will be easy. And they can start quickly and learn the system quickly. And also, it's their private development environment. We say private cloud stack.
Right.
So for them, they can do whatever they like. They can just do some changes, see how the system is working, and experiment with it. I think that's the fastest way you learn anything. You break the system, and then you see, okay, yeah, it works like this. So for them, it was really a gold. And on top of it, the core feature, I would say, one of the best feature was like benefit is collaboration becomes easy, because when we are doing a project, any project, we take people from different team and gather them together in an isolated environment so that they are never disturbed by anyone, because there are too many meetings. Everyone will agree that there are like so many meetings, which is really not important to us. So for them, like these project team, we call it project team, the collaboration becomes really easy because people from different teams can easily collaborate in the sense like, let's say we have a developer from the front end or the mobile app. They do not know about like how you run this Go services in the background or in the backend. Yeah, you can run them in the shared environment, but it was like, again, you remember the painful story of the shared environment? Yeah, definitely no. So for them, we were like, you just build a feature. You do not have to sync it with like staging or the production environment. Build them, give them the branch name. They can run it, the backend part of it, and then they can build. They can always mock the data for the initial thing, but they can actually make test and run everything in their private workspace. So in that sense, we were able to build everything really quickly and really fast. And people here like, what are you talking about? Like all this thing you talked about, this development environment in microservices, how does it relate to your talk show? Like, because you only invite people from like who is
oh yes, I do. Yeah.
Yeah. For them, like in order to conclude, I would say it's like since we were able to build faster, our usability increased because we were able to deliver things faster, and our client were able to use it really fast and roll out really fast, and we were building really reliably and really robust. So the system was really robust, usability increased, and that's where we were like, our system can handle this much request, and apparently it can handle 3 billion requests, as you can see in the other slides.
Amazing. Look, Rajan, thank you so much for sharing your experience. Unfortunately, our very expensive airtime is almost over. I would like to thank you personally because you're the best prepared person that ever visit our show. You had a slide for every question I had. That's amazing. And you guys, our viewership, if you want to share your experiences with Rajan or exchange them, take in contact with Car Rental Gateway and talk to him directly. Many thanks for watching. Until next time, bye-bye.
Thank you.